Welcome to Math with Mrs. Bibb. We will be discussing this week an important concept that you will need for Algebra 2, the concept of transformations, looking at equations and predicting with great accuracy what the graph will actually look like. This is week 29. There you can see your table of contents if you want to pause and fill it in. This is the table of contents for 2022. It could change in future years, but it is the table of contents for 2022. As you can see here on Student Journal, page 86, there is a list of vocabulary words. I'd like for you to read in your textbook, page 146 to 148, and fill in those definitions. You'll notice this highlighting over here on the side. You'll hear me refer to inside and outside often. Inside is a horizontal movement. Outside is a vertical movement. You can see I highlighted what corresponds with those. So you may want to remember that. And I've tried to include the green and the blue highlighting throughout the remainder of the notes. So here, you're going to see a lot of information, and it's going to seem so strange to you. And it's going to take a little while to really understand and comprehend. But I promise we'll work on it and work on it and work on it until this is something that you can look at and understand. The first thing there you see is a translation. It's a transformation that shifts a graph horizontally or vertically, but the size doesn't change, nor does the direction change. So we're going to talk about horizontal translations. A horizontal translation is a left or right movement. And when the number is inside with X, it's the opposite of what you would think. If you have subtract a number, that means right H units. If you have plus a number inside, that means left H units. Really and truly, when we're discussing horizontal translations as far as lines, I never really refer to horizontal translations because I really truly look at them as vertical translations. But it's very important to understand inside with X is a horizontal translation, and minus H is right and plus H is left. I want to show you some examples, and these aren't linear. I want to show you some examples of horizontal transformations. So to the left is horizontal, to the right will be vertical. So if I have f of x equals the absolute value of x plus 2, that represents a horizontal transformation or translation because this plus 2, sorry about that, let me undo. This plus 2 is inside with x, so that would represent a horizontal movement of left 2 units. If you had another graph that looks like this is a quadratic, x minus 2. Quadratic, you see that exponent of 2. And notice you've got minus 2 inside with x. That is a horizontal translation, a horizontal movement of right 2 units. So when it's inside parentheses, absolute value, then that's a horizontal movement, left or right. The blue over here, vertical translations. When you have plus a number on the outside, then that is a vertical movement. And I know there are many people that do not care for this phrase, but when it's on the outside, not with X inside, then I always tell students, it is what it is. So vertical movements up or down. If you have plus K, that's up K units. If you have minus K, that's down K units. So those are vertical translations, up or down. So let me show you some examples. I'm going to use linear to start with. So if I have f of x equals x plus, and I wrote minus, plus 7, then that, to me, that plus 7 is not inside parentheses, so it's on the outside, and that means up 7 units. I'll do an absolute value. Absolute value of x minus 7. So that minus 7 is outside of the absolute value. So that's a vertical movement. That means down 7. And let's do a quadratic. So that plus 7 is not, let me get my little pointer, is not inside. Inside with x means there's parentheses, like I'm indicating here. Inside with x. Inside with x would be parentheses. See, look over here. Inside with x. Inside with x. These on the right, the vertical ones, are all outside, away from x. And so those represent up or down. And again, I think you can recognize that this means up 7 units. Next, we have what's called a reflection. It flips the graph over what they call a line of reflection. With linear graphs, it either has a positive slope or a negative slope. And I want to point out, let me grab a highlighter, and I probably should have pointed this out on the other ones. This, well, that's not really true, but for this one, this line here is like your beginning function. Same thing over here. This line here, no, it's not. Pardon me. Let me undo that. This line here is your beginning function. And then you're reflecting it based on what it's asking you to do. I want you to notice the negative here is on the outside. That's why I highlighted it in blue. So when the negative is outside of x, then that's a reflection in the x-axis. And when your reflection, or excuse me, when your negative is inside with x, like I have highlighted on the right, then that's a reflection across the y-axis. Now, linear functions, the reflection across the x and the reflection across the y look very, very similar. Now, I want you to notice what it says down here. I'll highlight. A reflection across the x-axis multiplies the outputs, or the y's, by -1. And a reflection across the y-axis is multiplying the inputs by -1, or your x's by -1. So that's something important to remember. Now I want to show you a couple of examples of reflections in the x and reflections in the y as far as notation of equations. So a reflection in the x. A reflection in the x, I'm sorry for repeating. I had to pause for a moment. You can see I had these equations to write down, so I went ahead and wrote those down so it would be faster. A reflection in the x, the negative sign, whoops, I did not mean for that to be green. The negative sign is on the outside of x. It's not inside parentheses. That's all of those are examples of reflection across the x-axis of the parent function. And then these over here, when the negative is actually inside with x, grouped with it with parentheses or absolute value, then that's a reflection in the y-axis. Now the one issue or concern that I have is that honestly and truly, if you think about it, I'm going to circle them. The f of x's that I circled, those are actually the same thing. So a reflection of a linear function, the reflection in the x and the reflection in the y are the same thing. So I really always only call it the reflection across the x-axis when it's linear, because usually you do not see it written like this over here. You usually do not see that. So, but if you do see that and you say a reflection in the y-axis, that is perfectly fine. That's absolutely true. Let's go on to the next. Horizontal stretches and shrinks are one of the things that are difficult to understand for many students. I think the horizontal concept and the vertical concept aren't difficult to understand because you can see where here where the green A is and where the blue A is. So vertical is outside away from X and horizontal is inside with X. The other thing that you have to remember when you're doing the horizontal stretch or shrink is you talk about the reciprocal of that. Let me write down some examples. I'll pause and start recording again in just a moment. Okay, so I wrote down a bunch of information. You may want to pause the video and write down this information and then continue listening and writing down the other things that I write down. I'm going to do the examples. I want to talk about what these mean. So my first one I'm going to talk about is here. What does this 3 on the inside mean? Well, it's under the horizontal, so we know it's a horizontal stretch or shrink. And if you look at this here, A is greater than 1, and you can see I'm circling that with my pointer. You may want to write that this is a horizontal stretch. So draw an arrow and write horizontal stretch. When A is greater than 1, it's a horizontal stretch. And when A is between 0 and 1, that's a horizontal shrink. Now, when I look at this, and that may sound confusing, and I'm so sorry if it does. When I look at this, I know that this g of x function from the parent function is a horizontal shrink of 1/3. That's what this means. So that sounds so strange, but it is a shrink of 1/3. So let me write that, because that's what you multiply by. A shrink of, and I should say horizontal. A horizontal shrink. Sorry, I'm squeezing that all in there. A horizontal shrink of 1/3. Then when I look at this one, this multiplying by 1/2, I know that's a horizontal stretch of 2. We're doing the reciprocal of these numbers. The reciprocal of 3 is 1/3. The reciprocal of 1/2 is 2. And then you base the stretch or the shrink based on the 1/a value. So this is a horizontal stretch of 2. Okay, so when I get over here for these, there's no reciprocal. You don't change anything around. They're not on the inside, so all of these are vertical stretches or shrinks. And this is an example of a stretch. A is greater than 1, and this is a shrink. A is between 0 and 1. So let me, for this first one, f of x equals 5x. This is a vertical stretch of 5 because 5 is greater than 1. For g of x, this is a vertical shrink of 1/5. And over here and here tells you what that means by stretching or shrinking vertically or horizontally. And then this last one, 4 times the absolute value of x, that's a vertical stretch of 5. This part just summarizes many of the things that we said. So if you'll just read over that, you can highlight what I've highlighted. You can see that it does show you to do horizontal transformation first, then do the stretch or shrink, and then reflection, and then I'm translating vertically K units. I think a lot of times I like to do vertical first. We'll see that in just a few minutes for examples. So just read through that. I know it's going to be like this way, I have no idea. I understand. As we do these and look at them, you'll gain understanding. So try not to worry too much. Okay, here's some examples. Things that they want us to do. And really, our instructions are to describe the transformation from F to G. So we're just going to use words. Okay, the first thing that I want to do is look at the F function. So here's my original F function. Where is this minus 2 being put? Is it inside with x or on the outside? Well, it's on the outside. So that means that the f of x function is either being moved vertical on the outside, vertical is up or down. This represents down 2. So I'm going to put down 2 as my description. Now the book would probably say translated down 2 units, but I'm okay with you just putting down 2. Let's look at number 2. Here is my original f of x function. It honestly is from the parent function, which you'll see more about that later, but it is actually a reflection across it's on the outside, so across the x-axis and up 1 from the parent function. But we're not going from the parent function. We're just talking about from f of x. So what is this telling me to do? Put 2 inside with x. So inside is a horizontal movement. And I have to remember, inside, I'm going to write this word. Inside is the opposite. Inside means left or right. Outside, up or down. Inside means left or right. And when we think left, we think minus, but it's the opposite. So if we have minus, that's right units. If we have plus, that's left units. So this here tells me to move f of x right 2 units. Moving on to the next one. And I'm still reminding myself that I'm going from F to G. So from F to G, what is it wanting me to do? Well, here's a negative. Multiplying by -1. Once you've done these enough, you realize that's a reflection. I can go ahead and write that. That's a reflection. Okay, is the reflection inside or is it outside? Well, you can tell, obviously, that I said inside first, so it's inside. When it's inside, it's a reflection across the y-axis. Okay, number 4. Looking at my f of x function, what is this telling me to do? Okay, so I'm going to write down a couple of things. First, I'm multiplying by a number. That tells me it is a stretch or shrink. And it's either horizontal or vertical. Horizontal is inside, and we have to remember reciprocal. Vertical is outside. Now we can decide stretch or shrink here. You have to do the reciprocal, and if that reciprocal is greater than 1, then it's a stretch. If it's less than 1, then it's a shrink. And if it's on the outside, if it's greater than 1, then it's a stretch. If it's less than 1, it's a shrink. Okay, so let's look. Where is this 1/2 at? 1/2 is on the inside. It's on the inside. So that's here. It's on the inside. And then 1/2 being on the inside, I have to think reciprocal. So it's a horizontal. And then I think reciprocal. What's the reciprocal of 1/2? That's 2. So it's a horizontal stretch of 2. Let me write that down. A horizontal stretch of 2. Okay. Number 5. Let's look at this. Maybe we'll go back and look at our notes. I'm not going to write those again. Here is the f of x function, and here is the g of x. It has a 2 being multiplied. Multiplying by 2. So since I'm multiplying by 2, that's either a vertical stretch or horizontal stretch or shrink. So it depends on where that 2 is. The 2 is on the outside. Since the 2 is on the outside, that's a vertical, and then it is what it is, so 2 is greater than 1, a vertical stretch of 2. Okay, moving on to the next one. Here I have f of x, and I'm multiplying by 1/2. Okay, so let me put that out here. I'm multiplying by 1/2. Where is this 1/2 at? Is it on the outside or the inside? It's on the outside. So multiplying by 1/2 on the outside is a vertical stretch or shrink. And it is what it is, so 1/2 is between 0 and 1, so it's a vertical shrink of 1/2. And last but not least, it says describe the transformations. So from f of x to g of x. And hopefully you see there are 2. There's this and this. Okay, so what is going on? I have subtracting 2, and I have multiply by 3. Now those are not the transformations. I'm making these little notes so we can see. Subtracting 2, if it's on the outside, that's up or down. If it's on the inside, that's left or right. Okay, so where is that minus 2? Minus 2 is on the outside, so that means it's an up or down movement. When it's on the outside, it is what it is. So one of my answers is down 2. And then my multiplying by 3. Is that multiplying by 3 in parentheses or in absolute value? No, it is not. So it's on the outside. So it's a vertical stretch of 3. Now, I'm going to graph this. I'm going to graph the parent function first, or f of x equals x first. I'm going to graph that first. Okay, so when I graph that, I'm going to have 0, 0, 1, 1, negative 1, 1. This black one is the parent function. Then I'm going to do this next. I'm going to take the parent function down 2. So that's not my final answer. So I'm going to take this dot down 2 units. 1, 2. This one down 2. 1, 2. This one down 2. 1, 2. So that would be the graph of just moving the parent function down 2 units. And what are my ordered pairs? I've got negative 1, negative 3. I've got 0, negative 2, and 1, negative 1. To do a vertical stretch of 3, then I multiply your y values by 3. So my new ones are negative 1, negative 9, 0, negative 6, and 1, negative 3. And I'm going to do those in green. So my final answer will be the green line. And I don't know if I have negative 1, negative 9, but we'll just go for it. I'll just count off the graph. So negative 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Put a big old dot. And then 0, negative 6. So 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 0, negative 6. And then 1, negative 3. So 1, 1, 2, 3. So my final answer is that green graph. So from the black, let me trace, from the black to the green, we moved it down 2 units and did a vertical stretch of 3. I know that sounds wild and crazy. I promise we'll do more practice before we would actually have an assessment. Have a great day.